Hello, everyone. Welcome to the Analog Electronic Technology course. Today, we'll explore the RC sinusoidal oscillator. So, what is an RC sinusoidal oscillator? It is a circuit that uses RC components as a frequency-selective network to generate sinusoidal waves through self-excitation. As shown in the diagram, this is a classic circuit for generating sinusoidal waves. Let's take a look at the waveform it produces. The component parameters used in the circuit in the video are shown in the diagram. Let's see how it works. First, let's look at the op-amp part of the circuit, which can be simplified to this diagram. We can see that this is a non-inverting proportional operational circuit. This part of the circuit forms positive feedback, which is what we call the frequency-selective network. It consists of a series parallel RC configuration, known as an RC series parallel frequency-selective network. The expression is F equals the feedback voltage UF divided by the output voltage UO, which equals the result of resistance R in parallel with capacitive reactance, 1 over J omega C, divided by the sum of resistance R, capacitive reactance, and the result of resistance are in parallel with capacitive reactance, 1 over J omega C. Simplifying this gives F equals the reciprocal of the sum of 3 in J times the difference between omega RC and 1 over omega RC. Let F0 equal 1 over 2 pi RC, then F equals the reciprocal of the sum of 3 in J times the difference between F divided by F0 and F0 divided by F. It can be seen that when F equals F0, not only is phi equals 0, but F also reaches its maximum value of 1/3. Let's take a look at the waveform. After the circuit is powered on, the waveform's amplitude gradually increases from small to large, then stabilizes. As we've analyzed earlier, the maximum feedback factor of the RC series parallel frequency selective network is 1/3. Therefore, for the waveform to grow gradually, the amplifier's gain must be greater than 3. When the waveform stabilizes, the amplifier gain should be exactly 3. This function is achieved by the diodes in the circuit, which take advantage of their nonlinear characteristics. Now, let's summarize the main components of the RC oscillator. Amplifier provides signal amplification. Positive feedback network ensures the phase condition is met. Frequency selective network determines F0, ensuring the circuit produces sinusoidal oscillation. Nonlinear element, amplitude stabilizing stage, stabilizes the amplitude. A sinusoidal oscillator can be represented by the following block diagram. Once the circuit begins stable oscillation, the output becomes self-sustaining. That is, XO equals AFXO. When the loop gain AF equals 1, the system is said to meet the balance condition, which can be broken down into two parts. The absolute value of AF equals 1, phi A plus phi F equals 2 n pi. Amplitude in phase balance conditions. In addition, there is also a startup condition, which corresponds to the waveform build-up process. In this stage, the loop gain AF must be greater than 1. As previously discussed, in an RC series shunt frequency selective network, the maximum feedback factor is 1/3 when F equals F0. Therefore, the amplifier's voltage gain should be slightly greater than 3, with input resistance approaching infinity and output resistance approaching 0. These are the required parameters for a non-inverting amplifier. In the earlier circuit, we achieved a voltage gain slightly greater than 3 by adjusting the feedback resistor RF. If we rearrange the passive components in the circuit, The RC series parallel frequency selective positive feedback network and the negative feedback voltage divider network together form a bridge circuit. One pair of opposite nodes serves as the output voltage terminals, while the other pair acts as the net input to the amplifier. Therefore, this type of oscillator is known as a Wien bridge oscillator. In the circuit we analyzed, the oscillation frequency is fixed. If we want the oscillator's output frequency to be adjustable, we can replace the resistors in the frequency selective network with a dual-gang potentiometer. Additionally, a Zener diode can be connected in parallel with the negative feedback loop to limit the output amplitude, as shown in the diagram. In this lesson, we've covered the structure of the Wien bridge RC sinusoidal oscillator, the frequency selective characteristics of the RC network, and the conditions for generating and sustaining sinusoidal oscillation. That's all for this lesson. Thanks for watching.